All right, in this video, we're going to take a look at the compositions of functions. And we're going to start this section by evaluating the composition of two functions at a particular value for x. So in the past, we've talked about functions as machines that take an input value and process it based on what the function's defined to be, and then gives you back some output in return. And up until now, we've dealt mostly with just single values at a time. So, for instance, we take one number, plug it into a function, and it gives us back an output, a single output value. Well, in this section, we're going to look at two different scenarios. In this video, we're going to look at where we can take and plug a value into a function, and then the output it gives us, we can plug into a different function. So that's called a composition of functions. Or we can even take an entire function as input and plug it into another function as well. So composition of functions involves substituting one function into the variables of another, or using the output of one variable as input, or the output of one function as input for the other. So the composition of a function f and g is denoted f and then open circle and then a g of x, means f of g of x. And that's how we read this, f of g of x, where we're going to take g of x and plug it in for the variables where for f of x. So this open circle, again, means function composition. It's not multiplication, so be careful with that, especially if the circle's not drawn large enough. You might get this confused for multiplying f times g when it is a composition, so we want to take g and plug it in for f. So in other words, the output of g of x is going to become the input of f of x. So we'll figure out what the output of g of x is and plug that in for f of x. So here we have we're going to have an illustration here of f of g of 8, in which g of x is 2x plus 3 and f of x is x squared. So we're going to start with the function that is after the open circle. We always, compositions of functions, we always work from the right back to the left. So f of g of 8 means first we have to figure out what g of 8 is. Now g's whole purpose in this example is to double whatever you give it and add 3. So if we give g of x an 8, it's going to double 8 and add 3 and give us 19. Then we're going to take that 19 and plug it into f's function, which f is going to square whatever you give it. So if we take 19 and plug it into x squared, we're going to get 19 squared, which is 361. So again, the first thing we do is we evaluate g of 8, and we're going to get 19 from that. Then we're going to take that 19 and plug it into f and get 361. So example 1, find each of the following if f is 3x minus 4 and g is x squared plus 6. So f's whole purpose in these examples is going to be to triple whatever you give it and subtract 4. G's whole purpose is going to be to square whatever you give it and add 6. So we're going to start with f of g of 2. So f of g of 2, the first thing we want to do is we want to figure out what g of 2 is. So that's why I like writing it where we use just parentheses, because for me it's a little bit easier. But first thing we're going to do is we're going to evaluate g of 2. So g of 2 means we're going to square 2 and add 6. So 2 squared plus 6 gives us 10. Now we're going to take that 10, that output, and plug it into f. So g of 2 comes out to equal 10. Now we're going to evaluate f of 10. So plugging that 10 in for f of x, we get 3 times 10 minus 4, which is 30 minus 4, or 26. So f of g of 2 gives us 26. Part B, let's go backwards here. G of f of 2. So g of f of 2 means first we're going to evaluate f of 2. So we're going to plug a 2 into the function for f. So 3 times 2 minus 4, and that's 6 minus 4, or 2. Then we're going to take that output of 2 and plug it in for g of x. So we're going to evaluate g of 2. G of 2 is 2 squared plus 6, which is 4 and 6, or 10. So g of f of 2 is 10, and we see that it is not the same value as f of g of 2. So we switch the order for the composition of functions. That's not necessarily going to give us the exact same answer. All right, part C, f of 1. So we can even take the output of a function and then plug it back into the function as input. So we are absolutely allowed to do that. So f of 1, we're going to evaluate f of 1. So that means 3 times 1 minus 4, which is negative 1. then we're going to take that output of -1 and plug it right back into f. So 3 times -1 minus 4 is -7. So f of 1 is -7. All right, so that about does it for this video. Thank you for watching, and I'll see